Hello. Today I want to talk about what is a sample space in mathematical statistics. And this question actually confuses me for years. If you are having trouble, the same trouble, let's go ahead. Imagine a population, say capital Omega, is all the undergraduates at the US, including Alice and Coco. And we shall use a small omega to represent one particular student. For a question like, how many courses does a student take? In probability, we can define a random variable, x, that maps each individual to the number of courses he takes. For example, x of Alice is the number of courses taken by Alice. Assume that x follows a binomial distribution with parameter n is 12, p is 0.5. Then we can answer this question by applying the binomial formula, like this. However, things changed in statistics. Instead of just taking one x, we normally, in statistics, take something like x1, x2 from a binomial population where n is 12, but p is something unknown. Then we use the sample mean, x bar, as an estimator for the probability p. But here's something to think about. As random variables, both x1 and x2 are functions defined on the same sample space. Here is capital Omega. So for any fixed outcome, small omega, such as Alice here, x1 of omega is the number of courses taken by Alice. x2 of omega is also the number of courses taken by Alice. Because the omega is Alice, then why can x1 and x2 take different values? This brings us to the key point. In statistics, the sample space is normally different from the one we use in probability. How can we fix this problem? Consider a sample of size 2. In statistics, we first create a copy of the original sample space and define their product to be a new sample space, say capital omega tilde. Now we first pick one person, say Alice, from the first coordinate, and pick another one, say Coco, from the second. Putting them together as a pair, this pair constitutes a new sample, say small omega tilde, in the new space. Then we can define our random variable x1 and x2 for a small omega tilde in the new space by the following. x1 is the number of courses taken by the first student in omega tilde, which is Alice, sorry. And x2 is the number of courses taken by the second student in omega tilde, which is Coco. And we call this pair, x1, x2, one sample from the population because only one small omega tilde is sampled, and its size is 2. This idea applies when the sample size is any arbitrary n. We just take n copies of the original sample space. You can pause here for the details. And this is the answer to our question. In the end, I'd like to challenge you to think about the following questions. First, why not just let x1 and x2 have different domains? Say, x1 is on omega 1 and x2 is on omega 2. And second, what if n tends to infinity, just like what we did in the laws of large number? Thirdly, for an IID sample, what are we further assuming? And in the end, does such a sample space really exist or not? This should be answered in your second probability course, and I hope you enjoy them. Thank you very much.